Hi everybody, this is Simon and we are streaming live from HOFA Studios in Germany. Today's topic is about using an equalizer when it comes to mixing. So we are gonna taking a look at using an EQ for several purposes. And before we start with the details, I would like you to take a listen to 4 examples. You will hear an example without using an EQ, and right after that, there will be an EQ which slightly changes up what we're about to hear. So let's start with this little section from a song. We have a piano and a male vocalist. Here we go.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
All right, let's hear the same section by using an EQ. I won't tell which EQ that I used on these tracks. We will cover this later on, but just give it a listen, and I'm pretty sure that you will notice that there are some changes.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
It sounds a little bit different. The next example is a solo piano. And when it comes to the style and the sound, I would say it sounds quite jazzy. And you will hear some changes to be made here as well. Same example by using an EQ. Okay, so if we take these 2 examples, there are slight changes to be noticeable, and we're talking about using the EQ as a creative tool. But we can also think about making the things that we hear, making them sound even better. So, for example, if we have a speaker and some noise going on, there's also an option to use the EQ as a tool to reduce any unwanted noise. So here it is, the speaker with some noise.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars, and the first morning sunbeams around him made it almost unbearable for him. The city had long since awakened.
There's actually a lot going on in the low end. There are also some peaks and resonances that really affect the speech of the speaker. So, when using an EQ, it can sound like that.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars, and the first morning sunbeams around him made it almost unbearable for him. The city had long since awakened.
There's still some noise going on, but the EQ really helps us to improve what we're about to hear. Okay, last example, also an example for using an EQ in a creative way. It's an electronic track, and there are some changes even in the arrangement by using an EQ. So first of all, the example without any EQing, and finally, I'm pretty sure that you will notice that there are some changes going on. Okay, let's listen to the same section and song once again with some changes by using an EQ. We are going to look at all these examples in detail later on, and I will show you what I did and which kind of EQs that I used to make it sound as it sounds. And before we go into detail, I would like to take the word and talk a little bit about the history of EQs and what's it all supposed to be when using an EQ. So EQ stands for equalizer. So we are supposed to equalize something. That means we will either reduce and filter energy in certain frequency bands, or we also might add some energy. We can also cut energy, for example, if there is noise going on or any unwanted energy in frequency bands that might affect the music. We can use it in a creative way, but also in a slight technical way to make it sound better. For example, the third example with the speaker, where there's hum and noise to be noticed, and we can use a filter and EQ to make it sound better in the end. And let's start with some filter types. I'm pretty sure that most of you might be familiar with one or the other example, but I think it's a good idea to cover all of them to give you an overview what you are going to be using in the future after this workshop. Okay, so let's take this example once again. It's the second example with the jazzy style piano. And we're going to change it up by using different kinds of EQ. So you can either use the EQ section of your DAW and you plug in to your liking. For me, I decided to use the HOFA EQ because this tool really has it all. We have the usual EQ, the usual type of EQs. We could even do some advanced stuff that we won't cover today, but it's a really go-to tool if you're looking for a simple EQ to get the job done. Okay, let's start with so-called cut filters. A cut filter, like a low cut or a high cut, as the name says, it cuts energy and changes it up. Let's start with a low cut. I'll bring it in. Here it is. And as you can see, this is our frequency response, frequency bands. And if I set the low cut with the cutoff frequency, for example, at maybe 500 hertz, we can definitely see that this adjustment will have an effect on what we are about to hear. Yeah, I'm really cutting the low end and the low mids and the low end frequencies and almost everything that adds warmth and some, familiar feel to a piano sound. The fundamentals, which are very, very important to making a piano sound like a piano sounds like. So using cut filters can be a really cool way to really cut energy in the low end or in the high end, but it can also really change up an instrument and its character. So when using a low cut in this example, it probably might be better to not go up too high. For example, I'm focusing on maybe 80 hertz or maybe 60 hertz, but not too high because there's a lot of energy going on still in the low end. So for example, when I set the low cut at 60 hertz, I'm pretty sure that the piano will still sound like a piano. Okay, so using low cut filters is a good way to reduce unwanted noise in the low end. The other way around, using a high cut filter coming from the other end might be a cool way of changing up the sound and characteristic of the piano, because this example sounds really smooth and very, very likely, and therefore a very dull and dark piano sound might actually work for this example. So if I'm aiming for a rather dark sound, using a high cut filter by cutting the high end and the high frequencies might be a really cool idea. So let's give it a listen. I'll set the high cut filter at, let's say, 1 kilohertz, for example. And here's the result. So it really sounds smooth, and we still have the fundamentals going on in the low end, which are very important. But there is that kind of dark atmosphere now going on for that piano that actually suits what the piano player is doing here, in my opinion. So using a high cut filter might not be the worst idea when it comes to shaping the sound in this example. So cut filters are a cool way to cut energy in the low end or in the high end. Okay, let's move on with another example. Shelving filters. If we talk about a shelving filter, a low shelf or a high shelf, we usually have a cutoff frequency, and from this frequency on, we either push and emphasize the frequencies, or we reduce them. So for example, in this piano track, if I would like to add some high frequencies and push them, I could use a high shelf filter. So if I'm activating band number 4 and change up the filter type to a high shelf, I can easily add some frequencies that are going on here, starting at 2 kilohertz. So 2 kilohertz is my starting point, and everything around it will be pushed and added. So depending on the gain, of course, I can add some energy in the high mids and the high end. So here we are. I could also do this the other way around by turning it down. Similar to a cut filter, a high cut, but without cutting everything that's going on. Okay, I think you notice a slightly darker sound without cutting too much of the overtone structure that's going on in the high mids and the high frequencies. So we can also do it the other way around. So for example, if I activate band number 3 and then going for a low shelf, I can easily add everything that's underneath or beneath 200 Hertz in this example. So my band number 3 is located at 200 Hertz, and with the low shelf I'm actually pushing everything under 200 Hertz. And same here, I can also do it the other way around. All right. So let's move on with one of the most used EQ settings of all time, I guess, which is the bell filter. So we have a small bell-esque shape, and we use it for pushing frequency bands. So for example, if I go on with frequency band number 3 and go into bell mode, so filter type is a bell filter now, I can then push one frequency range or reduce it. Okay, let's do it. I'm at 200 to 30 Hertz, and we can see the bell. Let's go down. We are going to talk about the parameters that also play a role here later on, but there is a special type of filter that is almost the same as a bell filter, but we have a widely higher Q factor. So if I really increase the value for the Q factor here, we get a so-called notch filter. So this way I'm able to filter and reduce energy in small notches. For example, if there are resonances going on. I can also reduce energy, but I can also add energy. But usually we use notch filters to reduce some frequency bands that are really annoying. Okay, let's give it a try. As you can see, the effect on the actual characteristic and piano sound is not that much and not that audible, because we really filter only some small notches that might annoy us. So using notch filters is a really cool way to get rid of annoying frequencies. Okay. So I'd say that's it for now. Let's switch to another cool EQ, which is a little bit special, but also a cool tool to bring everything in balance. It's the tilt EQ. Tilt EQ, as the title says, is like a tilt between the low end and the high end. So for example, if we have our cutoff frequency at 1 kilohertz, I can then easily go for a tilt by adding some energy in the low end, by reducing the high end, or the other way around. Okay, let's do it like this. And let's have a check how it sounds like. As you can hear, we have less overtones and less presence in the high end, but also more energy going on in the low end. And the other way around is the opposite. Okay, and of course I can switch frequencies. I'm not stuck at 1 kilohertz. This was just an example. But using tilt EQs is a really good way to reduce the energy, for example, in the low end by adding some high end, or the other way around. This plugin is also a HOFA plugin. It's the HOFA Tilt EQ, and you can get it for free. So if you're open to using it, simply download our HOFA plugins manager from hofa-plugins.de, and then you can put a hand on the tilt EQ and get an idea about it, what we offer. Okay, cool. Some of you might be familiar with live sound engineering. So when you have to deal with a PA system or with monitor speakers that are located around the stages of this world, and usually it's not that easy to have a proper frequency response for a PA system or for these monitor speakers. And to get the job done, there are tools like graphic EQs. This example is a simple graphic EQ, which is part of my DLW that I use today, Cubase by Steinberg. And we can see the so-called ISO frequency bands, which are something like a standard. And we can actually also push these frequencies or reduce them. And this is a usual way of EQing a speaker system. For example, a PA system or a monitor system in any live surroundings. I wouldn't actually use this graphic EQ for EQing purposes regarding my piano, but in a live surrounding, when you work with a live mixing console or a monitor console or any public PA systems, then graphic EQs are a cool way to have many frequency bands, the so-called ISO bands, to put a hand on and to get a better frequency response out of it. Because you have to be careful when mixing live. Each venue might be different. So if you are in a big concert hall, you will have another acoustic surrounding compared to an open air festival, for example. So yeah, it's actually quite difficult to get the job done, but graphic EQs might be a good way to get a proper frequency response out of these speaker systems, but maybe not for our little jazz piano example. It's just to actually complete the circle. Okay, the last thing I would like to talk about in this step is the combination of filter types that we already talked about. So for example, if I bring back our EQ for 1 second, I can also have a combination of filters. So for example, if we take our first example, which is cut filters, I can have a low cut and a high cut at the same time, of course. So by activating them, I get something like that. And this will result in a really telephone-esque result and sounding. So this is pretty close to our first example that we had in the introduction of this workshop. And the combination of a low-cut and a high-cut filter is a band pass filter. So that's the type of filter by combining both filter types. Okay, that's it for now. Let's go on with the parameters. I already talked about the Q factor for a second. So if we talk about the basic parameters that are part of the game in our examples, or not only in our examples, we have, of course, the frequencies. So, for example, if I activate band number 2, we then have the frequency, for example, here at 50 Hertz that we can change up. So the frequency is probably what it's all about. And then we have the gain, of course. The gain is supposed to add something or to reduce something. But most important and next to the frequency is probably the filter type. So for example, we have the bell filter as a standard setting here in the EQ, but we also have the shelves and up there the cut filters that we talked about. So these filter types are very, very common in almost every setting that you can find and that you can use, be it in your DAW, for example, in Cubase or in Logic or in FL Studio, in Ableton. It's almost the same. But of course, the plugins differ a little bit, what it offers and how it sounds like. So our EQ is very neutral when it comes to sounding, but we could also use some SSL plugins that are adding additional flavor to the game. So these are coloring plugins by changing up the overtone structure and everything related to that. So it really depends on the plugin or the tool that you might use. One last parameter I would like to talk about is the slope. And the slope is actually measured in dB per octave. As you can see, I bring in the high cut filter once again. And here I can change up the slope. So if we have 6 dB per octave, it's not that much of a cutoff. It still cuts frequencies, but in a very, very smooth way. But if I go with 48 dB per octave, it's really straight. So we have a straight cut to get rid of the frequencies that are above our example, which is set at 1 kilohertz or 1000 hertz. Okay. So we talked about plugins, we talked about parameters, we talked about filter types, but now I would like to go back to the early days. So if we take this example here, as you can maybe see it on the screen, this is from a user manual from a almost legendary mixing console by Mackie. And for those of you that are familiar with different mixing consoles and how they are set up, we can see we have the input section, we have any jacks going on, but also the gain, the auxes, the faders, the routing options, the panorama knob, and also the filter section. So if we take a closer look at the filter section only, we can see that almost everything that we talked about when I talked about filter types can be found in analog consoles or analog devices as well. So if we start at the very bottom, we can see the low cut, which is set at 75 Hertz by 18 dB per octave. So I could reproduce this with the EQ. If we go one step further, we can see there is a low section where it says lows at 80. So this is probably 80 Hertz in the low frequency range. And this is usually a shelving filter. So we have a low shelf. And we only have the gain here, reducing it until to -15 or to +15. So yeah, this is usually a low shelf setting, but also a high shelf setting round about at 12 kilohertz with the same parameters. So the frequency, the cutoff frequency is actually set at 80 or 12 kilohertz, and then we can either have a low shelf or a high shelf in this setting. If we go one step above, we can see where it says low mids. In the low mid section, we have the option to change up the frequency. So for example, 220 or 350. So we are able to change up the frequency and then use the gain knob. So this is probably a bell filter, but we are not able to change up the Q. So if we have a small Q, we will have a very, very wide bell. And if we have a very big value for the Q factor, then it comes close to a notch filter that we talked about before. So this section is a semi-parametric EQ. And if we talk about a full parametric EQ, we go one step up and we have the high mids. So we can actually set up the frequency for the high mids. We can set up the gain, and then we have the Q factor, which is the bandwidth of our filter. So we have a bell filter with all the common parameters that we talked about before. So when we go back in time, when we used mixing consoles, when we used a lot of analog gear before plugins were available, almost all of these filter types have already existed, but were used in a slightly different way, in an analog way. Okay, so let's have a few more examples. We talked about filter types, we talked about a few examples where you probably heard about what's going on, and now I would like to bring in some more examples. So, how about this flute? Especially in the last section, I can hear there is some slight peaks going on. So if I use an EQ, I think I can do something about that. Okay, let's give it a try. So for example, if I use a bell filter in this example, I can probably detect if there's too much energy in the natural signal that was recorded. Okay, let's sweep through the actual signal to detect where there might be a resonance, and then we can try to soften it down. Okay. The cool thing is that we can also use real-time analyzers, as in this example, that will help us if there are any peaks going on. So once again, if I press the play button to listen, okay, I think there is something going on around here. And if I reduce the energy slightly, maybe by 4 dB, with a not too small Q factor, maybe it will sound a little bit better. So this is a way using bell filters, getting rid of resonances that might occur in our actual work as a mixing engineer. Let's take another example. For example, the snare. Snare, especially snare top signals, are usually supposed to sound very natural, but sometimes, depending on the tuning and on the drum heads being used, and of course the playing style, we have this typical ringing going on. Okay, it definitely sounds like a snare drum. So if we take a look at the frequency response, okay, so maybe I'm able to actually find something out about these resonance. Let's have a check. Yeah, here it is. Okay, so I can do something about that by reducing, maybe setting up the Q factor a little bit, almost having something like a notch, and I hope it sounds a little bit better. Okay, we gotta be careful to not reduce too much energy here, but it's a possible way to reduce the energy when it comes to ringing by these typical instruments. So also a bell filter or even a notch filter can help us to make it sound a little bit less aggressive when it comes to the ringing of the snare. Okay, let's go on with some guitars. So that's the same guitar. It's an acoustic guitar recorded by using a pickup, but also a microphone. Let's listen to the pickup signal first. To my ears, this sounds quite boomy. There's a lot of energy going on in the low end, in the low mids, but there's less presence in the high mids. So how about using a combination of maybe a bell filter and a high shelf? So as you can see, there's the analyzer, the frequency response, which our EQ also offers. We have a real-time analyzer, and when you compare the frequency response, we can already see that there is quite a lot of energy going on here in the low mids, but not that much energy in the high mids when we talk about presence. So for example, I could use a bell filter with a small Q factor and then also at a high shelf, maybe starting at 1 kilohertz by adding, yeah, some presence here. So how does it sound like? Without? And with the EQ. Okay, once again, without the EQ. And with the EQ. So this is just an option, of course. This is not the way to usually EQ guitars, but depending on the signals that we have, that you get as maybe as a mixing engineer, it's all about making decisions, and then you could reduce the low end or the low mids in this example, and also add some presence to make this element sound a little bit more crispy. Okay, but let's have the same guitar recorded by a real microphone. Sounds like that. Compared to the DI track and the DI recording, to my ears, it sounds a little bit more natural and more like a real guitar. But I think when recording this guitar, the focus wasn't on the body of the guitar, but maybe on the 12th fret. So we have a lot of harshness in the high mids, but not that much energy going on in the low end. Okay, maybe we can do something about that. How about adding a little bit of body by doing the other way around, something like that? And how about reducing the energy which is going on here in the high mid? So we have a combination of two bell filters. We add some energy in the low mids. We reduce some energy in the high mids. How does it sound like? Okay, A-B comparison. Once again. Okay, to my ears, it sounds warmer, it sounds less aggressive, and maybe we can work on the signal if it stands on its own or in the context of a song, for example. Of course, these examples are only options. It's not the way you would usually have to EQ any acoustic guitar. It really depends on the signal and what you are aiming for. But this is just an example using two bell filters by pushing up the low mids a little bit and reducing the harshness and the probable aggressive sound in the high mids. Okay. Let's talk a little bit about vocals.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
Okay, I'll try to EQ this on the fly by setting up a loop using the EQ, and we'll see what we can do about it.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep. But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
Okay, I would say the result doesn't sound that bad either. I pushed a little bit of the energy in the low mids. I reduced some energy in the higher low mids, but also in the usual mid range, because the singer sounds a little bit nosy there. And then I pushed the high mids by using a shelving EQ, but also a low cut filter. I'm pretty sure that I could set it up to maybe 100 Hertz, but not too much, to avoid reducing too much energy that's going on in the low end. But this is just a typical example. By using an EQ by 3, 4, or maybe 5 bands to optimize and to increase the quality of the signal. So not very much creative, of course, but the recording is almost fine, I would say. We used SM7B microphone by Shure, which is quite a really good all-round microphone, also for vocals. And I decided to increase the signal that I already have to make it sound better or more interesting by adding some presence, reducing some energy in the mids, and also using a low cut. Okay, so this is a typical way of using an EQ, a combination of different filter types. So now we talked about guitars, a snare, a flute. How about drums? So if we take this example here, maybe I can do something about that to use an EQ, making it sound even better. Okay, I think it doesn't sound that bad. Here's the kick. Good. So let's use an EQ. What I can hear is that there's quite a lot of punch, and the signal might be able to cut through in the mix, but the low end is rather weak. So there's not that much energy going on in the low end. Okay, so here we are. What did I do? I added some energy in the low end, in the fundamentals, to make it sound a little bit more energetic and powerful. And I also added some energy by using a high shelf filter round about 2 kilohertz, to make it sound even better when it comes to cutting through in the mix. Okay, how about the snare? Okay, maybe we can use a low cut filter here, because there's not that much going on in the low end section. But we could empower the body a little bit. For example, between 100 and maybe 300 Hertz, which is usually the range where the snare has its typical body sound. So something like that. And as well as the bass drum, we could use a high shelf to add some more crispiness to it. So for example, if we slightly add some energy here in the upper range, in the higher mids, it might sound cool. Without. There it is. Okay, and we could play the same game here when it comes to the typical snare ringing. Okay, maybe I'm able to find it and to spot it and to do something about it. Yeah, I think there it is. So maybe I can take a little bit out of it. So by a small notch, not too much, because we won't reduce too much energy to making it not sound too flat in the end, but a little bit might be helpful. Okay, doesn't sound too bad. When it comes together with the kick, okay, maybe we can increase the level a little bit. I'm actually happy, so I can work with these. So now we have the hi-hat. As you can hear, there's a lot of energy going on in the higher frequencies, so we don't really need any bleeding from the bass drum or from the toms or any low-end energy. So how about using a low-cut filter? This is too much? Yeah, something like that here. Okay, and how about adding some crispness as well? Something like that. Okay. And finally, the overhead tracks. We could also try to reduce any low frequency energies, but usually the overhead tracks are supposed to cover the whole drum kit. So we definitely want to have the snare on the overheads and some information coming from the bass drum and from the toms and the cymbals, of course. So EQing the overheads is something I would suggest to be careful about, and maybe not using any low-cut filters, but we could do something about it if you have microphones that really push the high end. So we could make it sound a little bit darker by using a slight high-cut filter with not too much of a slope value, or also we could push the high mids by using a bell filter or even a shelf filter. Or using notch filters if the snare ringing is too noticeable on the overhead tracks, then we could also reduce them, reduce the ringing by using a bell filter or notch filter to make it sound more balanced in the end. But yeah, that's actually really up to you, and it depends on the audio signals that you have. So let's listen to the result. Okay, I will now deactivate the EQs on all the tracks, and then we will have an A-B comparison. Okay, let's bring the EQs back in. Here we are. We didn't use any compression, we didn't use any reverb. We did a little bit of leveling and using some EQs on the tracks, and I would say the result isn't too bad in the end. The bass drum, the kick drum sounds more powerful, we have more energy in the low end, and the snare drum is a little bit punchier, and the hi-hat sounds more crisp, and the overheads aren't too bright in the end. So I would say, okay, this might be a good way to start when it comes to EQing drums and talking about the other tracks later on. Okay, we talked about combinations of filter types, for example, cut filters like a bandpass filter. Let's take this example. We have a bass guitar recorded by the DI signal, which is usually the output of either the amp or most likely the instrument itself, and a microphone, which is the cabinet. Okay, here is the DI track of the bass guitar. Okay, and here we have the mic. Usually, the DI track is supposed to bring in the low end, the low frequency energy, while the microphone also catches some of the overtones. Of course, a bass guitar is an instrument that has its fundamentals and overtones in the low registers, but we still have some overtones going on. So how about using a combination of cut filters? So the DI track will deliver the low end energy, while the bass mic track also offers some overtones, and we cut the low end energy and bring in more of these overtones. Okay, so here we are. Using a high cut might be a cool idea here. So for example, if we have the cutoff frequency at probably, let's say 120 Hertz for the DI track, we can then do the same for the bass mic signal and to filter to cut everything until 120 Hertz. So it looks like this. And then we have a combination of the two tracks. Yeah, they're both soloed, should work. Can then bring in some of the overtones here and maybe a little bit of more brightness to change up the sound of the bass mic guitar, bass mic track. So we have the low end for the bass DI track. And some mid-range energy and a little bit of presence from the bass mic track. So this is something like a standard way to EQ a bass guitar if you have two tracks, a DI track, but also a microphone track to bring them both together. Okay, let's hear it together with the drums. All right. Good. Yeah, there's something more I would like to talk about. We had our 4 examples at the beginning. So we know something about filter types. We know something about different EQs and EQ settings. So let's have a look what I actually did. So if we go back in time, here's our first example once again.
But then suddenly I am fraught with clarity.
And here it is by using an EQ.
But then suddenly I am fraught with clarity.
Some of you might already guessed right. I used a bandpass filter, which is a combination of low cut and the high cut. So here it is. I grouped both of these tracks, the piano and the vocals, and then used a combination of a low cut and a high cut, which looks like this and sounds like that.
But then suddenly I am fraught with clarity.
All right. Example number 2, the jazz piano track. Once again, by using an EQ. So what did I do? I used a high cut to make it sound darker and more dull. And I also pushed a little bit of the low mids to make it sound warmer. And then we get that result, which actually fits this piano sound, in my opinion. Okay, now to something completely different, which is the speaker with some noise.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars, and the first morning sunbeams around him made it almost unbearable for him.
Okay, and here we have the result by using an EQ.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars, and the first morning sunbeams around him made it almost unbearable for him.
So what do we have here? I used a low cut filter to get rid of the noise in the low end, but also a notch filter because there is a real resonance going on. So for example, if I deactivate these filters and go for it again, you can still hear what's actually going on.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars, and the first morning sunbeams around him made it almost unbearable for him. The city had long since awakened.
Okay, so once again, using the low cut and then also the notch filter.
He tried to look around, but the still glowing billboards of the arcades, the garish headlights of the cars,
and so on. So yeah, that really works to make it sound better and to get rid of unwanted noise. The last example was our electronic track. And here it is, and you can already see I used some automation. So if we start once again, you might follow up the EQ curve that changes up a little bit. Okay, so what did I do? I used automation. I automated one of the parameters, which is the high cut filter. And something like a usual volume or panning automation, but by using the high cut parameter and the frequency wandering from top to bottom and going back. And yeah, this actually changes up the arrangement because some of the elements and instruments and synthesizers and whatever is going on here is only slightly noticeable. And yeah, this gives a very, very different feel to the actual performance in the song. So yeah, using EQs not only in a way to get better results of the signals, but in a very, very creative way. And yeah, before we close the door for today, I would like to show you some or two of some more advanced uses for an EQ, because these are the very basics. But for example, when it comes to mastering audio, to have something like an electronic track that should work in a club, or if you're actual mastering for vinyl, it might be helpful and actual essential that the bass range should be mono. So it's quite common to have the low end and the low mids in mono until maybe 200 or 300 hertz. And to get this done, there are other tools on the market, of course, but you can also build something like a workaround by using our HOFA system plugin. In the mid side module, by using a simple parametric EQ, I changed it into a low cut to 300 hertz, a common low cut, but in the side mode. So it's not the stereo mode that we always talked about today, but the side setting. So the side signal gets filtered, and then we will have a mono bass. So for example, if we have this element here, which is a synth bass, it sounds like this, and the bass range is very wide. Now you can also see it in our IQ analyzer, which is also a cool plugin to get an idea of the frequency response, for example, of this element. Take a look at the correlation which is going on. This shows us the energy from the left and the right signal in the different frequency bands and the range. As you can see, there's quite a lot of energy going on in the low and almost with red rectangles. So yeah, now I use the trick by using our HOFA system plugin in the mid-side mode, using this an EQ, a low cut for the side signal. Let's see how it goes. As you can see, the bass range is mono, so there shouldn't be any problems for mastering purposes, for any club beats or whatever you are planning to do. Okay, another cool trick is using EQs not only for the signal itself, like a vocal track or the drums or any electronic thing, but using EQing on effects might be a cool way to have a very balanced sound in the end. So if we take this example, we have a vocal track that already feeds a reverb.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
It doesn't sound too bad, but the S sounds of the singer also trigger the reverb because we have a lot of reflections going on. So there might be a cool way to get rid of that. So if we take our reverb plugin, we can either have the built-in EQ, if there is a built-in EQ, or use an EQ right before or right after the plugin. So in this example, I'm using the IQ Reverb version 2, and here is my EQ. So this is also a combination of a low cut and a high cut filter. We have a bandpass, and as far as I know, the S sounds are around about 4 to maybe 8 kilohertz. So how about cutting these frequencies in the reverb itself, so the result might be a little bit more controlled using a bandpass filter. Okay, so this is a rather advanced trick, so you really need to listen closely to the changes because the reverb is still there, but the S sounds won't trigger the reverb too much. Okay, so maybe once again without the EQ and then with the EQ.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
Okay, now let's bring the EQ in.
But then suddenly I am fraught with clarity. I become aware, and now I see, like awake but still asleep.
You can actually hear it in the last section here. I'll turn it down.
And now I see.
And once again.
And now I see.
Okay, without EQ.
And now I see.
And with EQ.
And now I see.
As you can hear, the S sounds aren't too aggressive. They don't trigger the reverb too much, and we have more control and a more balanced sound. And the reverb is still there. We can hear it. It doesn't sound super huge anymore, but it's still there, and this will help you to make the vocals sit a little bit better in the mix, maybe more up front and less in the background, vanishing in all of these reverb, but also having the S sounds less triggering the reverb. And this could be a cool trick to using an EQ on your effect tracks. You can also do it for delays or whatever comes to mind. Okay, so this is it for today. Thanks for joining in. I don't know if there are any questions. You've been pretty quiet today, but that's okay. I hope that you can take some information from this workshop that will help and increase and improve your workflow for the future. Feel free to check us out at HOFA-College.com, and also feel free to get in touch if there are any questions. So have a good time, keep a stiff upper lip. See you next time.